JWST is the tool we developed. We started developing years ago for JWST. It's not just for imaging. Today we're seeing imaging, but it's also for spectroscopy and cubes and all other data sets, and also not just for JWST. So keep in mind that this JWebinar uses JWST data and is made to showcase JWST data, but JWST can be used with other data as well. So JWST is a Python package, open source, lives on GitHub. If you want to just Google it and find more information about it, there is the documentation as well. It has multiple configurations, some for spectroscopy, some for imaging, and today I'm going to show you Imviz, which is the one for imaging. There are multiple things that can be done with Imviz. One really good thing about JWST is that it can be used as a standalone application, just like you could imagine DS9 or Ginga or other tools that you just fire up and open and use as an app. But it can be used also in the notebook. So you do your workflow, then you use the visualization tools, you use JWST, and then you can get things out of it and continue with your workflow in the notebook. And the other good thing is that it is scriptable. So if you can do things with 1,000 clicks, but you can also do the same things by coding it up. And this is very convenient when you're passing on your workflow to somebody else, or you want to save the state of the application, save the state of the tool. You can just code it up what you've done. So you just run a cell the next time you want to do the same thing. So for this demo, I'm going to show you just the 1,000 clicks version, but there are cells at the bottom of the notebook that recreate the clicks that we're going to do together now. Feel free to interrupt me, because since it's clicks, you really have to see where I'm clicking and try it yourself if you want to follow along. So just interrupt me if you run behind. We will see a few tasks. They don't depend on each other. So if you miss one and you just want to jump to the next one, it's also fine. What we need to do all together is to fire up the app and fire up the data. So let's just see the first cell here. So the first cell is the import, and the first import is from JWST import Imviz, which is the configuration we want to use from JWST. The other imports are AstroPy and regions, because we're going to work with catalogs and the regions files that were created in the previous demo. So we need a couple of packages more to interact with these data sets. So let's just run this cell. On my machine, I do Shift Return, which is very convenient. I can also click on this icon here, the play button, to run a cell. This next cell is the initializing of the app and showing the app. So this is it. This is the application. This is Imviz. Let's get the data in first, and that's this other cell. There are 4 images, the same images that you saw before. It's the same Sears field, NIRCam number 2, in 4 different filters. And load the data. So it's parsing from the platform, data preloaded fits, JWebinar 38, and the file names are the ones that I just explained. So they're coming up, and here we are. So we have 4 layers here in the app. Produce this. Okay, and we can see it here. We have layer 1. You can see the name here is filter 115W. Layer B is F200W. Layer C is 356W, and layer D is 444W. They are stuck on top of each other, so we're just seeing the last one that we loaded now. But if we hit the B as in ball key on our keyboard, we can blink between the layers. So this is layer A, this is layer B, layer C, and layer D. I just hit B 4 times. Now, these images have been re-reduced by the Sears team, and they are pixel linked. They are all on the same pixel grid. But you know, if you were to load other data sets, they might not be on the same pixel grid. So what we do is we go to the orientation plugin here, and we switch the alignment to WCS instead of align by pixel. And this will flash a little bit, but because it's realigning everything to be on the same, like each pixel is the same sky coordinates. So we won't see any difference basically here because they were already aligned. But you know, for the future, when you work with your own data, you might want to do this when you load data from multiple telescopes or multiple pointings. So the next thing I want to show you is how to change the plot options for these data sets. So we go to this plot options plugin. And in here, we see the 4 layers again. You see that the diagonal lines, it means that we are not visualizing this layer now. The only one we are seeing is D, which matches what is here because we blinked. So now we only have the D layer there, but we can visualize the others. But let's just mess up with plot options for a few minutes just to show you what we can do. So there are some options here. We can change the color map. We can change the opacity, contrast, bias. You can feel free to play with it, or you can follow what I do. What I would like to do for these layers, for example, change to a Viridis color map. And I'm seeing it in Viridis. And then I can hit B again, go to layer A. Go to layer A here and change something else for this one. Let's see, maybe I can change the stretch for this one, 99.5. And so on for the other layers. I could do layer B, and I can change to a stretch function that is logarithmic instead of linear. You know, all these options are available to you to change the stretch functions. A prettier thing that we can do is we can create a color image. And we have a tool in JWST to create automatically a color image. So the first thing we need to do, though, is to show all the images. So we need to have all the images shown at the same time. So now I have A, B, C, and D with their own plot options. And then I can go to color mode here and set color. And now click this assign RGB preset, so red, green, blue presets. And it will automatically assign a color between blue and red to the images that I have. I could have 8 here, and it will still pick colors between blue and red, so that it uses all the images I'm tossing at it to create a color image. And then the default to make a better color image is the hyperbolic arc sign stretch function, because it helps with saturation, and the 99%. It's not the best color image, so let's play a bit more with this. And I know these images well. I've been working with this for a while now, so I can tell you that what we need to do is we need to change the Vmax, the maximum value for the stretch. And it's the same for the 4 images. It's a good number is 0.8. So we can select, instead of doing it 4 times for each image, we can select all the 4 images at the same time by clicking this button. So now I can select all 4 at the same time. And then I can scroll down and go to the stretch Vmax, unlock it because it was locked because it was different for every image, and set it to 0.8. And it will change it for everything. So just not to make a mess later, I'm just changing this back to 1 layer. This looks like a much better color image, and I did it with just a few clicks. Let's zoom in to see a bit more like the sources that are in this image, and I can click on this icon that is the box zoom. So I can click on this one and then go to the image and just select a random range within the image. You can select whatever range you want. I'm going here just because I know that there is a pretty galaxy here. I can adjust my zoom with the pan zoom tool. I have a handheld mouse. So what I do is I click and drag to move around. And I use the roll on the mouse to zoom in and out. If you have a trackpad, it depends on your settings. So how you set your trackpad to do zoom. On my trackpad would have been like, 2 fingers back and forth. That would be the zoom. So we actually created a pretty nice color image. And in the previous demo, you created catalogs for these images. When we work with these large images and we work with large catalogs, the first thing we want to do is to put these points on the image and figure out what source is what, especially if we're interested in a specific source or we are exploring the image and say, oh, I really like this one. Which one is it in the catalog? So we have this catalog search plugin. The original function for this catalog search plugin was to search outside catalogs like SDSS and Gaia and just show the Gaia and SDSS sources on the image. We then added more functionality to it, and the functionality that I want to show you today is the load catalog from file. And so if I click from file here, we can import the catalog that you all created in the previous demo. If you didn't create it here, you can navigate back 1, 2, 3, 4, and 5 steps and go into data, reloaded fits, the JWebbinar where we're working, JWebbinar 38, and in here there is a Photutils _cat.ecsv. So they're equivalent, the two. You can pick either the one you just created or this one that was previously staged on the platform. So I'm loading this one, and then I can hit search. It will think for a little bit and populate a table of sources, and then it would put points on the image. This is another the ones we call the Eigen bugs that appear or disappear sometimes. So let's try one thing here because it didn't put the points on it. So you can click this one and you will open the tool in a bigger window. And I wanted to show you this anyway, because if you have 2 screens, if you have multiple, like a large space on your screen and you want to work in the notebook and in the app at the same time, it's convenient to get the app out of the notebook. And so this is exactly what this button is doing. It's putting the app in a separate window. And now you can see the points that I was supposed to show you before. So we search the catalog. We have a table here of 30 sources. So it searched only in this area where I was zooming. I could also zoom out and do the search again, and it will return more sources. This is only 30 sources in this part of the sky where I'm zooming in. So it identified a few sources. The catalog that we created identified a few sources. What we can do next is to figure out what source is what. So I can go here and select the source, and it will highlight the source on the image. So I'm interested in source 2008. If your object ID is slightly different than what I have, is because these catalogs are creating, bottom up in the image. So if your background settings are slightly different, it could give a different ID to the source when the catalog is created, and that's completely normal. So don't worry about it. But it identified the source, so now I know that 2008 is that one. Let's unselect this one. I can do also the other way around. I can go here. There is this tool. There are more tools underneath this one. There is this little triangle here. I can click this one and get to this target. And then I can click the actual point, like this one. And it will tell me which source it is. Source 319 is this one in the catalog. So this is, for me, who I work with large images and large catalogs, this is so convenient. And I can also zoom to selected image. And it will just go deeper into the image to show me this particular galaxy that I'm interested in. Since I have only one last thing to show you, let's go zoom out a bit. I can also clear the selection. I can clear the table, and it will clear the markers out of the image. You know, when you start working with a lot of images, with a lot of catalogs, it can be useful to, clear the memory of the tool every now and then. So I clear everything here from the catalog search, and I go back to I want to show you the footprint plugin. It's the next thing I want to show you. So the footprint plugin is built to help you, guide you through, proposal preparation, for example. Here, by default, it put a NIRCam footprint on the sky at like the center of where I was in the zoom, and with a certain position angle 0 in this case. There are other footprints available here. I can put nearest footprint, for example. I can put the NIRCam footprint. This was taken with NIRCam, so it's very similar. I can also put, for fun, a Roman footprint. Haha. Roman, we'll see a lot more sky with just one pointing. So, but the next thing I want to show you is actually we can import, not just use the default footprints that we have in here, but we can import footprints or regions into this tool. So what I want to show you, I will delete this default because it's just showing too much here at the same time. So I deleted the default footprint here. I need to go back to the notebook because we don't have just yet an import from file for regions. So I'm scrolling down to loading regions. If you find this section of the notebook, this will load the file that was created in the previous demo where we had all the cron apertures. It's loading it from the preloaded data, but you could also point just the folder where you are working now and pull the region file that you just created. And we can run this cell. This calls the footprint plugin. It's already open, but it opens it in the tray. It adds an overlay to put all the cron regions, and it imports the regions from the file. So let's run this cell. And then we can go back to the viewer. It takes a little bit to import like 500 regions. So I'm waiting. Okay, that's done. And here they are. Here are all your regions that you created before. You can see it created these overlay cron regions that we named. We can change the color of these cron regions and say, I don't know, green, lime green. And we can zoom in again where we were before and see all these nice regions popping up. The last thing I want to show you is aperture photometry. You saw it through Photutils. Imviz uses Photutils to calculate quick look analysis and aperture photometry. So it uses in the specific the aperture stats function that you saw before. We can create an aperture. We can literally draw an aperture. I can pick this object and make it bigger so we can see a little bit of sky as well, bigger than the object. You can zoom in more and make a more detailed regions. I'm just going a bit fast here. So we are in aperture photometry plugin. We can select the subset. And because these are JWST images, it knows already where to go in the headers to find the pixel area, to find the flux scaling factor, to calculate magnitudes. If you have images that are not JWST, you can populate manually these entries because it doesn't necessarily know what header keyword to find. And we can plot a radial profile for this specific source. We can calculate. And here we see the radial profile of the source we're just looking at, and some values We see the magnitude, we see all the aperture stats that you saw before.